you probably recognize this shape. It's a tesseract, otherwise known as a four-dimensional cube. But most people don't really understand why this is a four-dimensional cube or what the fourth dimension is at all. In theory, a dimension is most simply explained as a way to describe the location of something. Here is one dimension, which is just a line. In this dimension, all you need is one number, x, to describe where you are. Here are two dimensions. You need two numbers to describe where you are, x and y. The same applies for three-dimensional spaces. You need three numbers to describe where you are. So the fourth dimension is just another way to describe a location. But what visually happens after three? Let's say I have one dimension, and I have a line. To change that line into a two-dimensional shape, we connect two of them together by each of their points parallel to the new axis. For three dimensions, we do so again, connecting each corresponding point. It follows then that we should connect two cubes together along the fourth axis. But we technically can't see it because we are three-dimensional creatures. What we can do is try to represent it mathematically as a fourth axis. But keep in mind, this is not a true fourth dimension. Now that we have the fourth dimension, we can continue the pattern and connect two cubes along it, just like we did with other dimensions. This is our four-dimensional cube of two regular cubes connected at each corresponding vertex. But it's not exactly what you would see in front of you. This is where the most common tesseract depiction comes in. But it looks like two differently sized cubes, one inside the other, instead of this typical mathematical depiction. So why is it different? Let's imagine for a second you are looking at a cube, but a 2D view of it looks like a smaller square inside another one, connected at each vertex. This is exactly what's going on with this depiction, except in 3D, a smaller cube inside another, connected at each vertex. So this model is just one that accounts for perspective. Another interesting property also arises from this. Perhaps the most famous thing about a tesseract is this process. This is what you would see if it rotated in four-dimensional space. But why does it look like this? Let's use the cube example. If it rotated in 3D space, a 2D view would see the squares distorting and changing shape. Similarly, when a tesseract rotates, a 3D view would see the cubes distorting and changing shape, which is exactly what you see here. So the fourth dimension is not as mysterious as it sounds. It's simply another way to describe a location. And when considering shapes in the fourth dimension, they just follow the same rules as lower dimensions, giving us some interesting 3D projections. But like many things in mathematics, this is only the surface. For all we know, there could be infinite dimensions. So all we have to do is keep looking.